What's going on, everybody? We're live. STL Sunday. Whole point of STL Sunday is to pick a project and draw it in 3D live while we discuss the methodology I'm using to think through a project, breaking it down into simpler shapes that we can actually draw. And tonight, and what we've been using during this entire series is Fusion 3D for the CAD program. It's a free CAD program. You can download it and go through the home use or personal use license path to get a free copy of it. Otherwise, it's a little bit hard to find that initially, but just keep digging. And if you're in the US at least, it is free. So at least currently as of the time of this filming. Tonight, picked a couple of projects in a way. What I did want to do tonight first was design up the welder and welder cart that we were going to work on last week, but kind of changed gears and went with a wheelbarrow instead. This week, we want to knock out that welder cart gas bottle, get that done, because I think that's a fun little project that we can do. The second project I want to do is actually less of a 3D printing project, but still something that kind of applies. And that is that I want to take a vehicle, in this case, and I want to kind of reverse engineer some parts so that then you could draw off of it. A lot of what we've been doing up to this point is just kind of drawing an item that would exist on its own. But many times you're trying to design an item that has to fit with something else. So I'm going to kind of go through my process of taking measurements and reversing an item that you have. And so that's the plan. Anyway, we'll get it. Thanks for everyone for joining in. Yes, I am on time. Well, let's see what everybody's got going on, see where everyone's checking in from. Canada, is it free? I believe it is free in Canada as well. I've got several friends in Canada that use this program, so I believe that you can download Fusion 360 and use it for free in Canada. How's the cat? Surprised to see you're on with the new member at home. Cat is doing really well. We got a new kitten yesterday, finally, after a very long wait. I flew to Phoenix and picked her up, flew back home. She did pretty well on the plane. It wasn't that stressful of a day, but we got through it, both of us. And she's adapting well at home. She's in her own area for a while to kind of get everybody in the house situated, let the other cats smell her, and we'll go through that whole process like they suggest. But she is super cute and pretty awesome. So looking forward to having her free roaming in throughout. Let's see. RC4 drive short wheelbase you built was designed with the Tamiya Jeep body in mind. Is that that's the idea of the rear body? Yes, I know that's the idea, or that's the plan of that, or point, however it was designed. But I was just building it as it was, and I had that one piece that was bad. That was it. So not terrible. Let's see, Michigan, Florida, two Michigan, right in a row. West Palm Beach, Massachusetts, Queensland, Australia, Pennsylvania, Michigan, Huntsville. Argentina is free, and Argentina is checking in as well. Do we have a name for the kitten? Yes, her name is Suki, which my wife got from a HBO TV show called True Blood. So, hey, 949 donated $20. I appreciate it. I think it's the first donation I've ever got on STL Sunday. Thanks. I appreciate that. Nice shirt. Yeah, it's appropriate for the day, right? And I like this shirt. It's super comfortable. Yeah, I did post the cat on Instagram. Thanks for checking that out. Is the Vanquish RC truck worth it? It is definitely worth it. It is the nicest truck you can buy, but I'm biased. KCRC checking in. John, thanks for joining us again. Colorado, Indiana, Atlanta. I was mixing those two together. South Florida, another Michigan. Man, we got a bunch of people from Michigan. Thanks, guys. Father's Day. Yes, happy Father's Day to all of you. Thanks for joining in still on Father's Day for many of you, I'm sure. Again, that's to you guys that are fathers and doing that hard work. Central Illinois, the Netherlands, Melbourne, Australia, and Mike P with $50. That's, again, appreciate it. Sorry for pressing you on ET on the SCX10 Maxwell, so here's peace offering. SCX10 2, I assume you mean, F9s and Rock Jocks are in production. Portals are a little bit slower, but I'm not sure which one you're after. Is another sponsor, the shirt. This one, no, this was a friend of ours in Kansas City that actually, it was a big Royals thing at the time, and his name was something, Eric Stoner was his name. Kind of a cool name. Stoner, they called him. His name was maybe Stone Street. I don't remember. Have Ben with $20. Keep STL Sunday going. Appreciate it. Oh man. More. All right. Thanks again, everybody. Cheers to you guys who are enjoying it. I'm drinking ice water. So to try and keep this stream reasonable, I'm drinking ice water. Let's jump into Fusion. So let's switch over. Here's the progress on my my newest project, which we were showing briefly the other day. CJ7-esque front end. And then it's going to have a Jeepster Commando rear portion of the bed. That is the plan. And my plan, all of these pieces are individual. So I can break this all get broken down. And then the goal will be, well, the bed is not done at all. It's all just work up front. But the idea for this will be to machine molds and then mold my own carbon fiber body. There we go. So, new design, jumping in. Tonight, like I said, let's work on that welder setup and welder cart. So, we went to the Harbor Freight website just because their photos always seem to kind of, they have good photos for some reason. The Vulcan welder, this is kind of the welding cart I'm looking at. A simple cart made to hold the welder and the cart and gas bottle. I think we can knock this project out tonight without a ton of work. So here's the plan. Let's start with the welder, this thing. Now, I was looking at this just slightly before the stream. And I think my idea for this is I'm going to break this thing down so that you can 3D print this in multiple colors easily. I'm going to break this center section out and do this front and rear section separately so you could print like black ends and an orange center without having to do painting yourself. And I think we're going to be able to knock this project out super quickly. And, well, a bunch of comments still going. No orange Yeti tonight. No, I've got this is a blue U-line Yeti. It's a freebie from when you order a bunch of U-line stuff. Matt's joining us. Easy on the money, people. He's going to spend it on cat food. That cat will eat. She is big already, and she's going to get very big. We have not shown the new kitten yet, and she's not in this part of the house yet, so I haven't. Will you show the carbon fiber Jeep work? Oh, I definitely plan to. I hope that it becomes my new Class 1 build. So fingers crossed that I get through that. I think we've all agreed that Suki is our new favorite, or is our favorite character on this show. Even without her showing yet, yes. All right, so we're in the document here. Let's make sure that you're actually seeing, yes, you're seeing the correct thing. I want to make sure that I'm not showing you the wrong screens because that's embarrassing. All right, we're going to jump in here. Let's start with that center section of this thing, the center orange section, which is going to be very simple rectangular. So we're going to start a new sketch at the top. Just trying to adjust things so I can make sure I can see what I need to on all of my screens. Okay, we're going to start a new section or a new drawing. We're going to start on the right plane. Start a rectangle. Just draw that. I'm going to hit L for line, X for construction. We're going to draw a midline through here just so I can constrain it to the origin. Just to get things started. Hitting the D key to dimension these lines. Now this is where we have to decide roughly what kind of scale we're going to have. We could look at this Harbor Freight website let's see, does this thing give us a scale? Or not a scale, but a size? Specifications, possibly? Here we go. Product length is 21, width is 12. That's probably, so we can go 1.2 inches wide, and what did I say? It said 27 inches long. Is that correct? Where'd it go? 21. Okay. So we're going to go 1.2 inches, which is what, 25, and almost a quarter is 6. So let's just go 30 millimeters. Going to round. And then high, it is, I mean, it is nearly as tall as it is long through that center section. But let's go with, let's go with 35 millimeters tall. Now we know what our overall length is, but we don't know just that center section. So on the panel over here, I'm going to go symmetric, and we're going to click this one, this button here. There's a half length and a total length. I always think in whole length, but sometimes I forget to toggle that. So we're just going to go with a, so if it was, what did I say? It was 2.1 inches times 25.4, 53 millimeters long is what it should come out to. So let's go 53 millimeters minus, let's give ourselves like 6 on each end. So minus 12. I do need to change my visual style to shaded with visible there. That puts those black edges on everything for us. Makes everything a little bit easier to look at. Now we need to put a couple radii on the top. Doesn't need to be very much though. It's not very pronounced. So we'll go with like a 3 millimeter radius. We're going to keep that pretty simple. This is really what we're going to keep this base to. Now I'm going to put just a couple of 1 millimeter radii there, just to break that up. So this piece, like I said, centerpiece, going to be super simple. One thing we could do is we could kind of shell this thing upwards to make it print a lot easier. Maybe we'll do that towards the end. Now we're going to start on the front panel. So we're going to select that. So now we're going to draw this front portion. I'm going to hit the P key to select this project window. That means we can just select this face and then hit enter, and it gives us all the line work from the outside of that. That way we don't have to redraw or trace that or anything like that. Helps things a lot. So we're going to do that, and then we're just going to do a quick extrude. And actually, I wouldn't have even had to do that P for project. I'll show you what we could have done on the other side. Like I said, we're going to add 6 millimeters. Now, rather than hit join, we're going to hit new body. So now it's going to be a separate component altogether. Now, if you want to visually kind of keep track of your bodies, if you hit the A key for appearance, why is it not popping up? There it is. You can bring up this materials over here. If you want to say paint, say we'll just go glossy. Is there an orange? There's a yellow. Close enough. Apply it to there. Now we can see this is clearly a separate body. Maybe that helps you just visually understand things a little bit better. Now, what we're trying to do is kind of create this front panel. One thing I'm seeing is that I think that this front panel portion is going to be deeper than the rear panel. So I was saying 6 per side. Let's go to 4 and 8. So I'm going to adjust the depth. Should the end caps be slightly larger outside diameter? I mean, well, that's not the one you need to see. maybe, sorry, dragging the wrong window down from my, um, I don't, to me, I don't think that those things look, I think they look pretty flush. I mean, maybe just barely slightly, but I think for the purpose of this, I just want to keep it fairly simple. So, like I said, I'm going to adjust that front. We're going to edit that feature, and we're going to change this to 8mm in the front. That gives us a little bit more to work with there. Now, this has got this slanted section here, as I'm kind of seeing. It kind of tips back in. So we're going to do a sketch on the right plane of this, or the front plane technically, and I'm going to make a cut. And well, first thing we're going to need to do is grab some, it doesn't want to snap to that top line. So this is where we're going to use that P for project. We're going to select these two faces. Let's just select all three just for, so now it brings all that line work forward. It gives us the ability to snap to those lines much easier. You can see those all the way around. Anytime you need to do that, it's a nice thing to bring forward. So we're going to select there. We're going to drag this down to some random point. I'm just going to close off this profile. Is there anything we want to do at the bottom? Now the bottom on this looks like it's got some shape to it, but it looks like it maybe just kind of goes in. Obviously it's got a recessed area there, but we'll add something. I'm just going to add a little kick in. So now we hit D for dimension. We're just going to say, yeah, let's say, whoops, not 21. We want to call that 2mm. 5mm tall. Call that 20. And that, well, I don't know why it kicked in. I have no idea what that just did. I don't know why it's doing that. Every time I put a dimension on that, it just wants to kick it out. Bizarre. So now we're going to select all of those regions and we're going to cut them through. So starting to create that shape. Now, the handle, God, sorry. We need to create this handle look because I think that's important to the style of this. So to do that, I'm going to create a sketch on this sloped plane. Once again, we're going to use P for project, and we're going to grab those two lines is all. So we may not even have had to do that for certain, but we are going to use them at least for, well, actually, I don't like that, so I'm going to undo that. Because we need to inset these lines, and I'll show you. What I'm trying to do is I'm going to create the path so that we can okay, I'm trying to think this through right now. So these handles, it's got that tubular shape that kind of goes around, but you can see it's not fully exposed. So I technically, I feel like I should set this back in further, not make the center line of this right on that front face. Will I post this on Thingiverse afterwards? Yeah, all the files that we create get posted. The whole point of this is we're going to draw something and then we're going to share it. So I'm going to undo what we just did. I'm going to delete that sketch. Then I'm going to go up to the construct area. We're going to hit construct. We're going to offset this plane here. And I'm going to offset it -2 millimeters. So down into that portion, it looks like it's a little bit far. We're going to go -1. The reason I'm looking at is I want to make sure that once we're done, I'm going to hit OK. I want to make sure that this front body, the handle that we're going to create, I want it to be so that the back side of this panel, of this whole piece here, can lay flat against the bed. So I don't want that handle to extrude too far into it. We're going to have to pay close attention to that as we're designing here. So sketch, select that new plane that we just created. Okay, it's on that new plane. So we're gonna use P for project. We're gonna select that face so that we have all of that line work. And something I'm gonna do is I'm actually gonna turn off that second body just so that I don't start selecting points off of it by accident. And quiet. So we're just trying to create some sketch line work. We have, this is even if this doesn't, I don't know, I wish I could just lock that window so I stop grabbing it. This isn't the simplest thing to do. It's not that difficult, but trying to make it simple enough and do it quickly. I think I know how we can handle this. So, and then here's my issue is that once we extrude a radius around that, it's going to come over top of this piece here and make it more difficult to 3D print. So we're going to actually, we're going to offset another plane, and I'm going to go I'm just going to go 1. I think that will give me an intersection point of those two. Yeah, that'll give me an intersection point of these two planes that I've got. It should be right even with the top of that. So I selected the new plane we created, and then projected that line work again. But it's actually, it reacts a little bit different in Fusion than it does in SolidWorks, sorry. Okay, we're going to try and move forward with this a little bit quicker. We'll come back and edit as needed. So I'm going to put a little bit of a radius on this, 4 millimeters for now. I'm going to Oops. We're going to dimension off this. Oh, it's not vertical. Horizontal constraints on these. We're going to dimension that off the wall 1.5 millimeters. Same on this side. And then off the top, we're going to go, 4 millimeters. Now we need to create plane at an angle. Oh, oops, that's not the one we need. It is plane at a point. Where is it? Where? Inspect. Let's see if we can pull that angle. So we need a 16.7 degree. For now, 16.7. Oop, wrong direction. Now we're going to do a circular sketch on that. We created a circle at the end of one of those lines, 3 millimeters in diameter. And now we're going to do a sweep out of the menu. So we're going to select our profile, which is the circle, and then we're going to select path, which is that sketch that we just did. We want to make this a new body as well for now. Here's where you can see my issue. I think we've got a couple of fixes that could easily be made here. But you can see I was trying to blend that into this piece, trying to make it kind of come into it a little bit more. One thing that we could do is if I put a radius on that of 1.5, everything will blend in much smoother yet. So I think we're going to move forward with that. That'll get us the style we're going for at least. And now I have a solution for how I want to handle the rest of this, but we'll get to that shortly. Let's keep making some progress for now. Let's combine those two bodies that we made. So there's the combine tool at the top in the menu. We're going to select that and then select this face and hit join. So that'll turn that into one part. Looking at the comments, sorry, I know I miss a lot of comments during this. I try and focus as much as I can, but one popped up. When you post on Thingiverse, can you see how many downloads? Curious how many 1/10 go-karts. I can see, it does tell me, but I have not checked. I'll have to, maybe I'll look that up for you guys once we're done here. So I combined those because I think what we could do, maybe we can just trying to add a radius there to clean that up a little bit. Is it not the same? Yeah, it is. Just doesn't want a radius the same on each side. It's weird. Yeah, that one does not want a radius the same. There must be something I did differently on one versus the other. Or on the, not one versus the other, but on that sketch. 1.5, 1.5. That's touching. So is that. Huh. Just don't know. That's very interesting. I'm just removing the constraint. I just want to try and see why this is doing that. Don't know. Either way, we'll get through it. It's a scale accessory after all. You guys will know that they're slightly different, but nobody else will. Be impossible to tell once it's printed. Okay. So we need to add a little bit of control to the front. I'm just going to add a little bit of a recessed center panel and then a couple of knobs. That sweep function is cool, would be great for roll bar and cage design. Yeah, the sweep function's super popular. Anything that's tubing style. The one thing is that 3D sketching sucks in Fusion versus some of the other programs. And there's a way that, like, right when you create the sketch, you can label it as 3D, and then you're in good shape. But it's really limited on what you can modify, and it's annoying in comparison to some things. So let's throw a rectangular-esque screen. Put that 3 millimeters off the top, 9 millimeters, and we'll call it 15 wide. Then we'll just do a hard center calc of 7.5 to center it. Let's see. Let's extrude that in, or cut that in 2 millimeters. But let's do one more cut on the face of this to kind of recess in almost this whole face. Just for a little bit more style. Call that one. Then let's cut that panel in 1 millimeter. Now let's throw some knob-like details. Then we'll put a large one in the center, a couple smaller ones on the side. Hit line for, or L for line, X for construction. Draw a line between those and make sure that is in the center. Just do a little bit of that to make sure everything is good. 10 millimeters sounds great. Both of those. Throw a couple dimensions on these things. 2.5 isn't terrible to print, so we'll keep that there. Knock these two down to 2.5. We'll leave this one at 5. Why not? Simple enough to add some detail. So if someone downloads this from 3D printer site and then they open it in Fusion 360, will they be able to modify it? Curious if there's something that 90% solution and just tweak the enemy. Kind of yes, kind of no. It's not easy to modify STL files because you don't actually download my Fusion 360 file. You download a STL file, which is a file made out of just some lines, some triangles, basically. It's not nearly as, it doesn't have as much information in it as this file does. So while it is possible, it's not easy to do. Throwing some simple radiuses on these just to, I think things always look better when you've got an internal radius at least. It doesn't look as, it's a simple thing, but I feel like it makes a difference. So next thing we need to do is we're going to put in some ports for like where your actual torch and ground wire, posit, whatever one is going to be. Now on this welder, you see that those are along the bottom. That's where you would actually plug the electrode in and turn it to lock it. For us, for the scale purposes, we're going to move it up to this larger panel just because I think it'll allow you more freedom for detail. Now at this time, let's think about what we could be using. I think that some wire that you guys have possibly in your toolbox would be the best solution for detailing. So let's find some wire and then base things off of that size. So I got a box of wiring here. Now, what do we have? This is a roll of 18 gauge wire. Now this is 2-conductor wire, so it's a pair that's braided together. What I would probably do is take this, strip it down, and just use the black, for example. But I think that a single piece of 18 gauge wire with the insulation is probably a pretty decent diameter to go with. So we're going to take a quick measurement just to see. Roughly 2.4 millimeter to the outside of the insulation, 2.5 millimeter to the outside of the insulation. So that's what we're going to use. 18 gauge wire. Somebody remember that so that we can make sure I put that properly in the description. So, like I said, 2.5. We're going to go to this front panel and we're going to put in, we're only going to put in 2 ports. Technically, there's usually 3, depending on the different types of whatever you're doing, or how your gas hooks up or your foot controls, things like that. We're going to keep this pretty simple. Now, rather than go right to the 2.5, we're going to go to 3 millimeter just to give yourself a little bit of room. Actually, man, I would even be fine with 3.5. Let's go 3.5, give you some room for glue and things like that. 3.5, that gives us 1 millimeter over the outside diameter. So at that, we're going to make sure it's on center. Not sure why it's not liking whatever I'm doing, but 15 is fine. And 7.5 will do it. So now let's grab those two profiles, drag them through to cut. Now, obviously, I don't want to go all the way through. We're just gonna, so we're gonna pull down that cut, objects to cut, and we're gonna turn off body 1. So it's only gonna cut into this outside panel. So you can see there, the front face of the next panel will be untouched. Still clean. Now, what we need to do is we still need a way to connect this front piece to that. And part of that is where my idea for how to fix my overhang issue here is. So what I think we need to do is I'm going to create a sketch on this right plane. And I'm going to hit P for project, and we're going to pull profile. We're going to strike a line that goes straight down. We're going to make sure that it is vertical, and then we're going to put a tangent constraint on it. That way we know exactly where that line is supposed to be. So that gives us that. We're going to inspect between them 1.607 millimeters. So I'm going to turn off that body 1. And what I'm going to do is we're going to create a sketch here on this back side of this part. We're going to grab that entire thing. Now, since we already combined this, it's creating this odd part here. I'm going to delete a couple of those lines out. And then we're going to strike an arc between them. We can do it a couple of different ways, but just putting in a filler for now. Since we defined that radius, we could just key it in, but I'm going to select the two lines and hit tangent. It's already good there. So now we're going to have the proper smooth radius around that area. But what I'm going to do now is we're going to offset this outside shape. Oh, I didn't have chain selection on, no wonder. There we go. We're going to do that with 2 millimeters. We're going to flip it to the inside. Hit OK. Now it has that. What I want to do now is extrude that whole thing 1.607. And we're going to do new body just because we need it. We don't need it to collide with everything. Hit OK. And now what we're going to have is, you can see how this whole panel is flush with this. So everything is going to, when you print this flat on the bed, it's not going to have a problem. You're probably going to want to print support material on the inside here, but that's pretty simple, pretty easy. Now we're going to combine that body and this. So, and we can hide this sketch here, which was that one. Now the only thing we need to do is we need to turn this one back on, sketch on this front, key for project, grab that outside line work, offset the outside, We did 2 millimeters, right? So let's go 1.5. Make sure that it's flipped to the inside. Wait, no, I need to go the other way. I need to go more than 2. I need to go 2.5. And now we're going to cut that negative 1.607. We can go exact on that just because, you know, a little bit of give will still look fine. So, oh, I probably need to make sure that it edit feature. It probably cut both bodies. I need to, oh, only did one. That's fine for now then. So now everything looks proper here, but we actually have kind of a keyed design. If you go to inspect and hit the section analysis, where is section analysis? There it is. And just select the side and you drag it through. You can see that this outside portion keys over that inside body. And that gap in there is just that extra that we kind of left. So there we go. I've been neglecting comments completely. I'm sorry. Use 3D filament for the cables. You could. It's just, I don't know that it's flexible enough, because what I'd want to do is like, I'd want to spool some of this off and then kind of coil it up and put it on the side of the welding cart. And I think that, I guess you could take the filament and heat it up a little bit in the shape that you wanted. But if you use rubber wire like that, you know, it'll be easy. But if you don't have wire like that, 3D printer filament's probably a really good idea if you heat it and kind of put it in the coil you want, and it'll just be permanent like that. Probably a real decent idea. Only regret on a 3D printer was realizing I waited too long to get one. That is a great sentiment, I think. I think anybody who's big into this hobby, you'll easily be able to figure this out as much. So, you know, just as much as an RC car. So now the only thing we don't have is we don't have a SFL said that my holes look off center, and I think he is correct. Let's fix that. There we go. Fixed. He was correct. Need to redefine that. I don't know why. I still have an error on that, but I'm not super worried. So I want to put a couple of things to clean this piece up. Does that. And like I said, we need to connect these. Technically, I think you'd be just fine with gluing them, but I usually like a mechanical fastening. So right between these, let's do a 3.2 millimeter hole. Actually, let's do it. We'll go 20 millimeters in. We'll hit OK. But I need to go back and edit that because I did that a little bit too large at first. Rather than, we're going to go 2.5. So that'll give us the threaded. That way I don't have to redefine my sketch. I can just go back to this, snap to that center. We can go 3.2. That'll give me the pass-through for a 3 millimeter screw. And we'll go in, was it 8 millimeters? Yeah. So, oops, not positive 8. We need to go negative 8 as a cut. So now you're going to be able to take a 3 millimeter screw. I'd probably use a button head. I mean, let's clean it up even a little bit more. Let's kind of countersink it. Let's go with a, oops. Let's go with a 7 millimeter countersink. That's 4 millimeters deep. So now when you can put a button head or socket head in there, it'll kind of sink back in. It'll disappear from view. I think it'll look pretty decent. Let's save this so that we don't get we don't crash and possibly lose our data like we almost did last time. Right? Simple there. Now we just need to add a very simple rear panel. And the rear panel, I don't even know if this thing probably does not have a picture of the rear. There it is. There is almost nothing on it other than a power plug. So we're gonna call that pretty simple to draw. Let's start with a new sketch on the back side. Let's hit P for project. Well, actually, that was the thing. I didn't even need to, so I created that sketch. I didn't even need to do that. What we could have done is just selected extrude, select that panel, grab it back. You know, well, I was gonna do 6 and 6, and we were gonna do 8 and 4 now, right? 4 millimeters, new body. Okay. So we got that. Let's now create a sketch on this back. Hit P for project, grab just the 2 vertical lines, and then we're gonna basically extend those up, over, back down. Make sure that they're in line with those vertices. Now we need to make sure that wish I could pull that center point off of that thing, but it doesn't want to let me snap to that. It always wants to snap to stuff when you don't want it to. There we go. We've just projected it onto there. So we need to snap that to that center point. Why won't you do it? Nope. All right, let's create a point. We'll do that. There, it did it. So now we created a point. Still doesn't. I think that got it there finally. Let's put a radius on here. I think we did 3, didn't we? So done 4. Oh, anybody see what I screwed up? Because I do. Remember how we brought these in last time? I forgot what I did. Lily is watching my new cat. She must be on the phone with Nicole. Hello, Lily. Thank you for joining again. So we're going to offset these again, 1.5 millimeter on each side. We're going to project that handle again, so that gives me that midpoint. Let's see if we can drop a point on there. And Now let's throw some radii in here. This thing is being so bizarre with some of this. Okay. Couldn't he just copy and modify the front? I could, but I don't want it to, like this one has a lot of different shape. It's laid back, the rear is straight up and down. This rear panel, I don't really want it to look the exact same. So for the most part, I think that we'll be in a much simpler state to go this route, which is why I went this way other than so. Now we're going to offset that plane. $18mm down. Should have been 17.5. So that gives us the plane to draw our, well, I didn't need that plane at all, did I? I could have just used the default top plane. And from there, we can draw our 3mm circle. So now we have our path and our profile. We can go back, we can use the sweep tool. Profile is this circle. Path is that line that we drew. And we're going to create this as a new body. And hit OK. So, gets us that. I don't think that's too bad. But one thing, oh, that's fine. We haven't combined it yet. We're going to grab this front face and we're going to throw a, let's just do a 1mm radius on it. So it radiused everything before, and now we're going to combine those two bodies. Or actually, undoing the combined, let's do a radius on those two end pieces first. 1mm radius. Now, combine them. So this one now isn't as easy to print as this one, because this one's going to start on the print bed here, but this one not so much. Still okay. Won't be that difficult to print. I think you guys will be able to handle it. Maybe a little bit of support material, a little bit of cleanup. Not a terrible thing. We're going to do one more of these sketches where we create that overlapping function. P for project grabs us that outside. An offset of, what was it? 2mm. Flip it. And, oh wait, actually we did the outside, not the inside. And we're going to take that in 2mm, new body. Then we'll combine it. Lastly, we need to now offset the outside -2.5. Cut that in 2mm. So we've got overlapping or keying pieces, keying design to the two. We'll do a section analysis just again to make sure that everything looks like our overlaps are looking proper. Got enough clearance. Not going to be a problem. Let's create a panel in the rear, and then we're going to call the welder portion of this thing done. Line, L key for line, X for construction. Just going to center this there. We're going to cut that panel in. Let's see. Now, if we cut 2 millimeters, we're going to go all the way through, aren't we? Because this one's thinner. Because we only have 2 millimeters. So we're only going to go 1 millimeter. A very shallow. And then let's do, we're going to do first our cut to hold everything together, 2.5 millimeter cut. Actually, let's do that cut, and let's do another circle. We'll just kind of pull it next to it here for the power cable, the power cable like you would plug into the machine, right? We said what do we do for the front? 3.5? I forgot. We're going to go up here. We're going to use the inspect tool and click this circle. That is a 3.5 millimeter diameter, so I remembered correctly. So we're going to cut that in. Cut that into both. For this one, since it's so thin, did I do that in the front? I didn't in the front. I only gave you so much depth there, but in the rear, since this panel is thinner, I'm going to cut that into the body just to give you the extra room. We could do that in the rear or in the front panel. Wouldn't be a terrible idea. But we still need to add the pass-through size in the front. Oh, we did have 4 millimeter. Huh. Guess I could go. We had 3 millimeter. Either way. Okay. So this cut, that first cut could technically be, we could go to negative 1.5. Give it a little bit more depth. Think we're basically going to call this welder done, unless you guys have any other suggestions you'd like to see on the welder, keeping it pretty simple. There's not much I want to add. We're going to put this thing on a cart still, so we got to bang out this cart. And 18 gauge wire for the welder. Yes. Let's see what else you guys come up with. HD on it. See, someone's always better at remembering this stuff than me. What panel should we put it on? We'll just put it on the side. Text is HD. Font is Impact. Height, we'll go 16 millimeters because that's a weird number. Then we'll just change it by dragging it for some reason. We're gonna be weird and just put it down in the corner rather than in the center because reasons. We're gonna do 0.4 millimeters. Nice and tiny. Screw hole in the bottom to secure the welder. Sure, Good idea. Who knows where you guys may or may not use this. Let's do 2 just in case. Well, here's a example. We can go to visual styles and then go with hidden edges. And now, wow, those don't want to work for crap. But the reason I was doing this is you can see the see like this very faint line here and here and here. Those are the other holes we have in the body already from the this bore that we have for the screw. See where it goes. Then we've got a couple more back here for the other screws. So we want to make sure that we don't collide with other areas just because you don't want your hardware to interfere. But if you're using a short screw, it shouldn't be an issue. But at the same time, if we go in the center, it's not a concern at all. So my 2 screw idea has been abandoned. 2.5 millimeter diameter, select it, and I'll just give you 13 millimeters. Yeah, why not? Why not? Do 4 corner for feet. Not a bad idea. It might, let's see. Depending on how you print it. Well, actually, we could do the corners, the feet on these front and end pieces and make it pretty simple, couldn't we? We could. I like that idea, but I'm going to leave it for now because I want to get to this cart and we're already taking way too long. I think we're not going to end up getting to the reverse engineering of anything. So there's the welder for now. Let's move to the cart. I do like your feet idea, Bill Moore, but sorry. I might need to mount this welder on the go-kart. A welding trailer for the go-kart? Not a bad idea. Okay. Now, the welding cart. This is the cart style that we're after, and we'll knock out a gas bottle as well because that should be just super quick. So for this, let's break this thing down into some simple shapes. Let's kind of do an outside shape. And how are we going to make the platforms? Because we need to put axles on it for wheels. We'll probably try and reuse a wheel that we used on, I think we were using go-kart front wheels on almost everything, right? Save it. Someone's making sense over there. Saved. Okay. Let's make some hasty decisions on how we're going to draw this. I'm just trying to think of the easiest way so that you can print this thing super simple, which I'm just thinking is side. I mean, we could make easy trays that really just drop onto those areas, but God, it seems like we could come up with better. Can we? Can I? Can I quickly? That's another question. It's not coming to me quickly. We don't have a great solution to that. I don't. So we're going to create a sketch. We're going to start on the top. I'm going to start with a base on this thing for some reason. Not 100% sure why, but we're going to do a couple of things. So we need to make this thing wider than our welder, which was, let's say 30 millimeters wide. So we're going to go with 35 millimeters wide. And our welder front to back should have been closer to 28, but what do we got here? How did we end up 53 millimeters long? Did I forget what the dimension was? That's not too bad. That seems longer than I was planning. What did we do? I don't remember how we ended up so long. I'm doing that correctly, right? 53 millimeters. What did my... Sorry, everybody. I'm just going to go back. This thing should have been... Wait, where was it at? Specifications, right? Specifications. It was 21 inches long. So that, oh yeah, no, 2.1. Okay. I'm right. God, I am having a brain fart. I was thinking it was supposed to be 21. I'm good. Thank you all for reassuring me that I wasn't losing my mind. 53 millimeters. Okay. Sometimes you do this stuff live and it ends up all funky. Now we need to make sure that we also have room for a bottle on the back. So let's say a normal bottle is, I don't know, call it 10 inches in diameter for, what is there, a Q size or S size? I can't remember. Let's just call it 12 inches in diameter. So, and we'll just go, so 1.2, or sorry, even just 25, that's 25 millimeters. We'll do 1 inch. 8-inch diameter bottle? Does that seem reasonable for that? Let's see. Calculator, if we go 8 divided by 12 is, let's see, 0.667 feet. So, you know, let's see, 0.667 inches times 25.4 is 16.9, 17 millimeter diameter. Ten inches is pretty standard. Okay, we'll just go 18 millimeters in diameter, right? So I'm just gonna put this in there for reference, 18. And then we need, I'm just gonna put a rectangle in here as well. And it's gonna be 30 by 53. Now those are just, I could have done those as construction. That'll give me just a reference for everything. We'll get this all confined down to a center point as well. All right. Just Googled an argon bottle at 9 inches by 50. Okay. We'll use and 2 bottles, MIG and TIG. Well, you could use argon for both, right? You know, you don't have to use C25. So these lines here are not things I'm using for construction. I'm just using currently for, or not for profiles. I'm just trying to use it to choose the size. So we went 35 millimeters there. Let's make this, what's 80 look like? I think that'll work. It'll give us a little bit of room for an argon bottle to sit back there. Welder B. Now, granted, we have to, let's go 85. Yeah? Yeah, that'll work. So I'm going to kind of use this as add another tank at 7. You guys in your dual bottle setups. Who's got the money for that? This is 3D printing. We got to save that filament. Let's see. I'm going to go down 5 millimeters just for now. We can change our mind later if we want. We need to open up our go-kart though, because I need to check what our go-kart specs were. That was an 18 millimeter diameter. Draw this, dimension it at 18. We could put that basically on that bottom edge. Keep it towards the rear. Let's go, yeah, 8 millimeters seems good there. Inside, we'll go 2.5. This is just going to be where we end up with a 35 join. I know it didn't create the axle hole properly, but that'll give us a way to mount our wheels, our rear wheel at least. In the front, we need to add kind of like a caster. And I'm gonna print this base with basically, I'm gonna try and make the base so that the top is what will print face down. So that gives me a little bit of freedom with these bottom wheels. So I want these casters to be reasonable, but not extravagant. So we're gonna make them just built in basically. I'm gonna make a bit of a shape here. Now, one thing we need is this was 18 millimeters. So we need to make sure that it stays at that same level. Obviously, that caster looks... Now, technically, these would never touch. I'm just going to make them touch for simplicity of printing. This is going to be a very oversimplified piece because it's going to be pretty small. I go like 5 millimeters in. That seemed fine. Let's get that off of that right on the corner. I'm gonna bring that in just a smidge. Just to kind of have a little bit better look from the front. I want that to close up better. There we go. Now, even though it's not, oh, got these So technically these are currently separate bodies. Since they're separate bodies, one thing I did is I drew that right on the edge, which if I wanted it to look good is not the best. So being that it's a separate body, I can select it with this move tool and just move it in a 0.5 millimeter. And we actually are fine. Now I'm going to take and I'm going to mirror that part. We're going to select that object, select our right mirror plane, hit OK. That's weird. It did not mirror it moved in. Okay, either way. Now they're combined. They're a very simple caster, but this super hard undercut edge is not great. So we're going to throw a 0.5 millimeter radius on that. It'll fill it in. It won't look too bad. It's simple. So paint these things, detail these things up with a silver Sharpie to look, you know, metallic-y, and you'll be fine. They're going to be so small and underneath of this cart anyway that I don't think it's going to be a big issue. And we still need to, so my thought was that I wanted the wheels, I wanted a base that was somewhat structural to this. Those go-kart wheels that we have, we can actually insert those into here. We go, oh man, is it insert? Save this. Welding part. That's weird. It won't let me open my folder. I don't know. We'll do that again in a second, because that's odd. So we're going to start adding an upright section. Just kind of looking at my sketch of where the welder and bottle will sit. And I think I'm going to attach kind of the side pieces and the front handles. Looking at these, you can see that rear piece is one, and then the front handles are another. Technically, there's a section that kind of does this whole thing. We're not trying to replicate it exactly. We're just going to try and get the look, which I think we'll be able to do without much of an issue. Just studying it for a second. Okay, let's do, is there any way that I could, I'm going to combine, can I combine the welding plate? What I'm looking at is, I'm wondering if I can combine this tray where the welder sits with this piece here. I think that even though it would be printing with a bit of an overhang, because it's at a slight angle, if it was straight perpendicular to each other, it wouldn't even be a concern. But even with a little bit of a draft, I think most printers will do it. I know my printers will do that without an issue. I think that yours will too. So let's create a new sketch. We'll go, how do I want to do this? I'm going to do an offset plane. We're going to offset this plane, and we're going to take it to just the back area of where the welder will sit. Can't see the cart. You should see the cart, right? Oh, yeah, sorry. I know. I drug it down there in a minute, a little bit later. My bad. So 13 millimeters, that's fine. We're going to sketch on that plane. We could do another another swooping path. Let's do that. We're going to show that this thing's kind of bolting to the outside, even though maybe it won't in the end. But it's going to overlap at least. Make those even. Just make sure everything's nice and centered. Let's put that, let's put it, yeah, 1.5 off the wall. We'll do a 4mm radius there as well. And now we need to determine how high up that's going to go. So looking at this thing, needs to go to the top of the welder. You guys agree? So our welder is that says 37. That's at a bit of an angle, but it's also not to the top. We'll say, let's just say 40mm. So 40mm, we need some space underneath of it, say at least 20. So let's go roughly 60 to the top. You guys good with that? So that's going to be that. We're going to create a sketch off of the bottom. And rather than doing a round tube, we're going to do a rectangular 3x3 line X. Gotta make sure that those are mid. So we've created a rectangle along that path. We're going to go up, hit sweep. In our dialog box here, profile is that one, path is the rectangle. Then you can see it creates that. We're going to make sure that it's a new body. Hit OK. I'm going to take a break and have a drink, catch up on comments. Save it. Saved. A small recess for the bottom of the bottle. I think that's a good idea. We should do that. Let's do that while you guys get any other suggestions in. I think we did an 18mm bottle, right? Is what we were thinking. So we'll go with a 20mm recess. You guys get the rest of your suggestions in while I'm just detailing this up. $30mm back. It's not exactly lining up with what I had, but that was, like I said, it was just for there we go. Go down 2mm. Yeah. And we'll put the smallest of internal radius. 1mm internal radius. Top of the base is the bottom printing, so no so I think with this little bit of a recess, being that this is going to flip upside down, I think you'll still be fine with that. It's going to be so small and it's going to be covered that I think your printer will bridge that small gap without any support material. I think you'll be good. Do you know why? Oh, Futaba got really expensive, $329 now. I actually don't know. I didn't see that the price went up. Who hates cutting out a welding hood? Oh man, let's just try and get done what I can think I can get done today, let alone a hood as well. So, like I said, simple there. I think that'll get us started. Now, what I was thinking is that while this does show an overlap, I think what I want to do is I want to create a small, let's see, panel, something like this, 4 millimeters tall, maybe we just go 8 this direction. And then we're going to make it and make sure that it's in contact with that. And the purpose of that is I'm going to hit new body just so that it doesn't collect everything. But the point of this is that I'm going to connect these two pieces so that I can actually attach this piece to the cart without having to like try and make super small connection points through these side things. And I think we'll be able to hide this panel decently well. I'm going to go like that. And then maybe still throw $10. But we're going to do that, and that's going to help. That's going to help hide. We need to combine these two bodies. Then we can add a small radius in the corners for strength, like that. Now we'll pop a hole through this and the base, and we'll screw up from the base into it. It'll be nice and clean. You won't see much, and things will start to get more held together and secure. So, like I said, I want to try and make the welding tray and this upright one component. So now let's do that. We're going to have to define our edges. Or define our edges, or define our angle. So I am going to, this is not a line that we're going to use. That's going to be a construction line, but I just wanted to figure out how far forward I needed to go. So this is where we need to come up with an angle. We'll drag this down again so you guys what we're looking at. So that angle there, the cart, it's slightly up, not too much, but just a little bit. Let's say like 10 degrees maybe. Shit, that's 8. Let's go 5. I think 5 degrees is enough. So, and that's not much of an overhang. A 5-degree angle is a very tame overhang that I think any of you guys who have a printer, you're probably more than capable of doing a 5-degree overhang. A lot of these things will do, 30s and 40s. Like, if you do a calibration print or a test tower, you're probably easily going past that. So we've got our angle. Oh, we need to define this height. And I think we said we were going to go 20 millimeters off the base. Now I didn't give a lot of compensation for, so we're gonna go 20 millimeters to the deck where the welder will sit instead. So not a ton of height, but a little bit. We need to grab that profile. I think that will be all right with this. Now, does that leave my, yep, still leaves my body separate, still looking good. So my goal would be to print this thing laying on its back. Like, it's hard to rotate sometimes in every angle you want. But I think you lay this on its back laying down and you print this upwards, we'll be okay. So we need to print, or we need to design up our front handles. Create some mounts, a bottle. We're gonna do all right. Yeah, my CR60 will do, my CR10 will do 60 or more. Yeah, exactly. This is gonna be nothing for you guys with those printers. Like just, you're gonna have no problems whatsoever. Especially any of you guys who are taking time and tuning things and wonder if Josh knows what KISS means. Yes, but there's a different, you can make things simple, like you can make all these individual parts, but you spend a little bit more time designing, you're gonna be able to print it faster, it's gonna be stronger, you're not gonna have all these little pieces of hardware. Just saying. Sometimes simple and, you know, I think that there's always a better way, right? Okay, let's do another handle. And how do we want to do this one? Because this one's got, in this case, it's got these kind of funky upward handles, which is not something I guess I have seen myself all that often. Add tabs or holes for the chain around the bottle. Yeah, we do need to add something for that. I agree. It definitely needs those chains. I think what we'll do is we'll add a plate on the back side to give you guys the ability to do the bottle chains. So how are we going to do our front handles? We're going to do it. Actually, we're going to offset a plane. This front plane, I just need to go 1.5, negative 1.5. We're going to project that face just because I'm going to grab that line work. Not all of it, but some of it. How far up do we need to go? Those handles. So they go, in this case, they go up just over the height of the rears even. So we do need to go up a ways. Maybe we'll change our mind. I don't think I'm going to match that exact style because I want them to print. I want it to print together just because I think that that's a better design for 3D printing. What is that? 69 millimeters because I'm a child. So Vertical handles are supposed to make it easier to push the cart. Why don't shopping carts have vertical handles then? That seems silly. I disagree with their logic. What if you got to get over like a, zip tie? You got to lift it up a little bit. I think this vertical handle thing is crazy. I actually still don't like this now. How do I want to change this? We're deleting that sketch. I don't like it. We're going to sketch from this side for now. Okay. Yeah. We're going to go up and then over like that. $10mm. We're going to go from there. Okay. We'll go 2.5. We'll set that thing back in just a little bit. And we will extrude 3mm or offset 3mm rearward. There's that. We're going to new body. Now, I'm not agreeing with the vertical handle thing yet. You'll see what I'm doing. Objects, this, mirror plane, right. And we're going to go with a rectangle, 3-point rectangle. That. So we've created something like that. I'm going to do let's do a 7mm internal radius. Since this is 7mm internal and a 10mm external. So now we have something that looks like a curvy cart handle. I think we did too big of a radius. Let's change those. Let's do a 3mm internal and a 6mm external. That looks better, right? Agreed. I agree with me. Now let's add a couple of cross pieces that we need. First, we need to grab this line work. Oops. I'm going to do a rectangle, 3-point rectangle. We're going to go from there forward because, well, actually, I need to do a rectangle that's not square. Polygon, not a polygon. I guess I'm just drawing it myself. Was it parallelogram? Is that what I need? what is my total width there? 5.5. That's not terrible. So the reason I would rather put this to the back side, but that's my flat side to print on, so I don't want to put it there. I think we'll clean this thing up a little bit in a couple of ways. New body. I have some plans. So we're going to do a how much room do I have? At the bottom. Yeah. I agree with Mike. What did Mike J say? Someone said about making sure the welder will fit, though. I will. That's a good point. We will make sure to do that. Let's oh, how we did that. I picked a oddball surface there. Oh, I didn't cut that. I was trying to add some items earlier and it wouldn't let me attach them for some reason, but I think we're going to be okay there, I think. Let's save first. Got a lot of stuff open right now. Guess not too bad, but so that's going to be 3.2. Oh. What's going on there, but let's just modify the feature. Okay. So now we're going to be able to attach the front handle and the rear. We're going to put a cross brace under there so everything sits. We'll get there. Let's do a bit of a countersink to make sure that 6.5. I think the head of a screw is 5.56, basically. Let's go 5.75. We're going to keep that one pretty tight. And the head is 1.7 millimeter tall. Is that right? Yeah, 1.8, 7. Negative 1.8. So now you'll be able to countersink that screw. The welder will hide most of it if you move it to the forward. Move it to the forward. That's how you say things. All right, let's see if it will. There we go. Now it's opening. Welder, insert. Well, let's move to group. That's okay. We'll just move it, copy it. You rotate it back 5 degrees. Oh, look at that. We have a problem. Slide right there. Everything else fits pretty well though. So let's adjust our rear handle. Let's increase that to 65. That's going to work. Doesn't even look absolutely terrible. Looks halfway decent. We are definitely not going to find time to do another project after this, though. My apologies for being a little overzealous with what I thought I could get done. So let's clean up the front of this a little bit. Actually, I went too far on both those. I have another idea. Let's turn off the bottom. What is this sketch? Turn that thing off. Never mind. I hate that idea too. Clean this up slightly at least. Let's go something like that. Now we're going to combine that piece and the handle. That'll get that closer in order. One thing we could do to help kind of lock these in is we could create a sketch on that back plane. Let's do this. And then, so we just created a triangle or a rectangle there. Oops. Ooh. Extrude that area. Just drag it back like 5 millimeters. We're going to make it a new body. And then we'll throw we're going to combine those. So now it's got like a flat spot that it wants to touch and hold on even. And to make it more printable, since it's on the draft, the underside. Actually, we're going to chamfer it. I like chamfers in those situations better. I don't like how that one was looking. Let's do it the other way. Just a little bit, just to make things fit together nicer, look a little better. Hole in the base to mount the welder. Yep, well, we're gonna have to put a hole in the bottom too, so you can actually get a screw to it. Or at least maybe you could put the screw through and then just a smaller hole just for your driver tip. I think we could do that. So let's go bottom. We still have a lot of work to do on this piece, but we're gonna go visual style, hidden edges. Now we don't have to get this thing exact. Well, we could. Let's hide that. And then I think we could pull that one in. And then we can just do our 3.2. Let's give ourselves, let's go to 3.5 on that to give ourselves a little bit of wiggle room since it's, since we're dealing with kind of a wonky situation. 5, it's only cutting one body, so that's good. So now we've got our hole to mount the welder. We need to make the cross piece like this rear one. We haven't put a hole in either of those, so we still need to do that. Sketch. Why it's and we need to, of course, we got to keep in mind again where we're going. And I should have almost moved this whole thing back first. Would have just been, I might still, I think we'll be all right. Extrude that across 35 millimeters. Make sure new body. Combine those two so things connect. That chamfer. Okay. So now we need to we need to actually mount the top and bottom. These need to be 2.5 because we're going to attach these from the underside. I'm just going to make sure that these lines or these circles are centered on those parts. Now let's cut those through. Now we just need to make sure that this bottom hole is large enough for our screw to pass through. Again, I'm going 3.5 on these just because you got a lot of moving parts and you never know about plastic shrink rates possibly being a little bit different from printer to printer. Try and make it easy enough for everyone to get one of these assembled. Okay. That should put those two. So now we'll just, we'll work backwards through this. Let's hide the welder. So we have our base. We go to attach this piece and it will screw together with that hole, which looks good. This will all just kind of be floating out there. Then when we add that part will attach to this crossbeam with this screw and will attach to the bottom with this one. And I think that looks like a welder cart to me. Let's insert those front go-kart wheels. I know you can actually like assemble these things in a proper way, and I should be doing that. But we're getting there regardless. Let's see. One other thing I want to do is I do want to, no, I'm not worried about it this time. This time we're not going to. Feel like you can put a washer behind there if you want, just to give it a little bit of a standoff, but mirror that item, mirror plane, right? Never once. I need to do this almost just as much for the thumbnail as for visualization, so we got to make sure that it looks right on the Thingiverse listing. Oh, and it lost our material properties on the cup. That's dumb. Oh well. Okay, there's that. We need a bottle, right? So let's add a bottle. Oh, we need to add the plate for your guys' bottle chains as well. So let's get those couple of things. Ooh, we're definitely going to be tight on space for those bottle chains, huh? Ruh-roh. Maybe we'll add them to the outside. Material properties, I mean like the appearance properties. See how I have colors added to these? When you hit the A key and it pops up this here. So if you click faces, you can add all of this. But it should have brought that in with it, and I copied it across. I thought it would have kept it in the copy, but it didn't. So either way, we need to create the bottle still, right? A hole in the bottom plate so you can get the driver in. Another good call. Create a hole here. Change the visual style so we can see hidden edges. We're going to make sure that this hole is... Now we're going to make this hole big enough to get the screw through too. Just because things are getting pretty tight under there, it might be a pain. We'll go 7mm hole. That's plenty big enough to get a screw through. So you guys will have to throw some junk on the bottom so it covers that up. But that'll allow you to get the screw and your driver in to attach the welder to the cart. No, mount the welder first, then the bottom. That's just as logical of an idea. I agree. I'm leaving the hole. Just because I know myself, I'd get this all put together and then go, crap. I should have done the other thing first, and then you'd be like worried about breaking stuff. So we'll add, yes, Travis, like Travis says, a hole for the bottle. We'll do that as well because we can't totally rely on those scale chains. But now we need to create the bottle first. So I'm grabbing that profile. Let's hide those wheels that we brought in. So let's also grab that profile. So now we can actually see the bottom outline of where that bottle should be. And we're going to go up. We're going to create a bottle half. So someone said what? Like they say 50 inches tall? So that would be 5 inches tall. So 5 times 25.4, 127 millimeters tall. Okay, now let's get, can we actually, what is the design of a argon bottle? Just wondering if there's like a profile of an argon bottle. Can we get an image? It's a pretty good image, I would say. It's one of these websites that's not going to allow me to save the picture though, is it? That. Just save image as. Save it on my desktop. Desktop. Save that. Now let's insert from my computer, my desktop. So now we're going to move this roughly into position at the bottom like that. Then we're going to hit OK, just like that. And then we're going to go, so that brought it over here on the side to canvases. Open the canvas, and then if you hit right click and go calibrate, and then you click on the bottom and you click on, we'll go all the way to the valve. And then it pulls up this little dimension thing. You see that down there? And we can just type in 127. And that will get it the right size. It scaled it not how I wanted, but let's see, Y direction, or is it Z direction that we need to go? Do I need to go 10 millimeters up? Whoops. That was Z angle. That's just, oh, that's just the, that should definitely be the Y direction. So. Too much. We'll go, oops, 8 millimeters. Still too much. 7 millimeters. So now we have the argon bottle in there. And we can start sketching. So I'm going to have a flat bottom rather than the true shape of an argon bottle, but that's mainly just going to be for 3D printing. And we're just going to arc that. We're going to simplify. Now let's do it kind of. And let's, oops. I'm thinking let's do that top. Let's do that bottle top separately. The valve itself. We're going to go through and add some connecting. That. Put a few dimensions to this. We're going to go, oh, we were going to go 18 millimeters. Is that what we, yeah. Oh, it's going to, sorry, 9 millimeters because we're looking at the radius. Then we're going to put a radius on the bottom. 4 millimeters is fine. Now we need to revolve this. So we'll finish that sketch. Revolve, the profile is that we just drew. The axis is this line. New body is selected. Now we can turn off that canvas. We're left with something that looks like a bottle. I'm just going to clean up a few of these small areas where they should have radius. So secure, yeah, I plan to add something to make it look like it's secured with a chain, but I want a screw in it just because I think maybe you guys could find something that looks like a scale chain, something more, realistic in that way. So I want you guys to have that ability, but I want you to be able to have it super secure with an actual screw in the bottom. That way, if you're moving it around on your bench or somewhere like that, it's not always like falling or tipping around and being super annoying. So that's the theory to the reason I was saying that. Put a 2.5 millimeter screw hole. That goes through both. One more just for clearance. 3.2. So now you have an argon bottle. We need a valve still, but last thing we need is some chains or a way to hold some chains. Oh, I was going to put a plate all the way across the back, but I think that's going to be more difficult now. Jewelry chain is close to proper size. That's a if any of you guys have some jewelry chain that you want to cut up for this. It probably doesn't need to be very thick either. The plate, not the chain, especially. It's time to get some blue PLA for my Miller guy, and Ben gave me $10 again. Appreciate it, Ben. Thanks for the donations tonight. Let's go. Okay, so we're gonna do that, and it's still gonna give us room for your power lead to come out. We're not gonna have a lot of depth to offer here, but if we go -2, it does start to collide with the welder a bit. -1 point. I guess we're just going 1 millimeter. That's really all you need. So we did that, but we need to add some slots for chain. Let's go 3 millimeters wide, 4 tall, and that should give us 2 that we can use here. Make that. I think 3 millimeters is too wide. We'll go 2. There we go. So you can put your chain through those slots now. If you need them a little larger, you can always file them. Make the hole in the bottom bottle 1 to 2 millimeters less deep than the screw you decide to use in it. That will allow the bottle to look loose in the cart yet be held on. That's true. Just put a short screw, or put a, the screw that you use, and it'll still jiggle around. Or better, yeah, like you're saying, for that jiggling effect, let's go with a 4 millimeter hole in the bottom. That way the screw can even, it can still move around, because you only have so much play in this dish as well. So now you'll have a little bit of movement for your bottle, but it still won't come out. Good call. I like that idea. Welding carts always suck. This one will be no different. I think is that it? Oh, we still need a valve, right? Need a valve? Can I do that off camera? Do I need to do it here? Let's just knock something quick and dirty out. Argon regulator. So we have the regulator and valve combo generally, right? Can I just put a top on it like it's not being used? Can I cheat? Can I just chintz out on you guys in this one? What do you think? Can I put just a bottle cap on it? A screw will look good enough for a flavor, in my opinion. If a screw would look good enough, I think an integrated bottle cap would be more than good enough, right? Right? See what the consensus is in the comments before we decide. No. I think you can do a bottle cap. It's pretty late for us. I agree. It is getting late. Let's adjust our revolve. Let's put a cap on this and call this thing done. The cap would just, that's too small. Where was that revolve? You need to make sure that this is tangent so that we get the proper top. Like that. And that should still print well. There we go. I think we nailed this one enough for tonight. throw a little bit of different color on these just so that they don't look. So you can see the differences between some of the bodies. Close. It's a small bottle, I agree. It's not, it could be bigger. It's not the size of the bottle, but the way you use it. There you go. So I appreciate all you guys who hung out. I didn't watch numbers about how many people were in here, but it seemed like a good group. So I appreciate all you guys. Again, any guys who print these, if you tag me in your Instagram story, I'll make sure and reshare them. I don't always see tags that get done on regular posts, but if you just post it regularly, share it to your story as well and tag me there, because those like stay at the top of my feed. So I'll always see those. You know, just so do that, and I'm happy to reshare them. I always love seeing when you guys actually print these things. So I'm gonna blow this thing apart, get them uploaded to Thingiverse. I'll probably upload this all as one item rather than the welder separately and the cart separately. We'll put it all up there, and again, I hope to see some of them. Thanks again for joining, guys. It was an awesome night. I'll have this uploaded in the next like 20 minutes or so. I'm just gonna get it uploaded right away. Check the video description of this video and I'll have it updated. Download the files and go from there. Thanks again as always, guys. Appreciate it. These are fun for me. I was glad that we had a good group tonight, because when this stream I get isn't as much into like the rest, like everybody who's into RC isn't into this, but you know, when streams are slow, it's like, man, is it worth it or not? This was a great one though. I really appreciate it. Thanks for everyone for showing up. So happy Father's Day again. We'll see you next Sunday for this, Monday, or wait, Tuesday for Scale News Update, Wednesday Takeover, so much stuff. Thanks again, guys. See you next time.